So this is again a typical question which confuses people if you are not careful that momentum being a vector quantity, right? So you can very easily arrive at the wrong answer, right? So let's look at this. A ball of mass 0.15 kilogram, right? So there's a ball which has a mass 0.15 is moving horizontally with a speed of 3 meter per second. It's going to collide with a wall. Okay, and after the collision it comes back with the same speed. Okay, it comes back with the same speed like that. Okay, and we have to find how much impulse is delivered to the ball, right? So we know the impulse is going to be my change in momentum, right? But if you're not careful, if you don't look at the direction of the momentum, basically you can say there is no change in momentum, right? But actually there is, right? So first, my initial momentum is towards right? And how much is that? My P initial is towards right, which is going to be 3 into the mass, right? The 3m is my initial momentum towards right. And my final momentum after the collision is again going to be P final. This is 3m, but towards left. Okay, so we can call it minus 3m and we can call it plus 3m, right? So how much is the net change? So net change here is going to be P final minus P initial. Okay, so my P final is minus 3m and then minus plus 3m. So net change is going to be minus 6m, right? So which is suggesting that the momentum has actually changed by this much amount in this direction, right? That is why we have this final, this one, but it was going in the other direction. So net change is minus 6m, right? And that is going to be equal to the impulse. And that is also going to give us the direction of the impulse, right? So it is not 0, but double. Okay, so minus 6m, and that is going to give us the impulse. So let's multiply this. It's going to be minus 6 into 0.15, right? And that is going to be equal to how much? You can simply find that out. 6 into 0.15, that is 0.9 Newton second with a minus sign, which means towards left. Okay, so the ball will experience an impulse by the ball, which is going to be in this direction. Okay, towards left. Okay, so that part 1 is solved. Part 2, if the ball was in contact with the wall for 0.1 to 5 seconds, find the average force, right? So that's very simple. The impulse is also going to be F into the time it takes. My force average is going to be the impulse divided by the time. Impulse we have already calculated 0.9 Newton second, and the time which is given is 0.125 seconds. So we simply divide 9 divided by, 0.9 divided by 0.125, and that is going to give us the force. Okay, so that is going to be 7.2 newtons, right? You can see the seconds get cut. Basically, our force which is going to apply on the ball is going to be 7.2 newtons. So what is happening here? The ball is moving towards right. When it comes in touch with the wall applies on an average a force of 7.2 newton. As a result, there's a change in momentum, and that is going to be equal to the impulse, which we have already calculated, is equal to 0.9 Newton second. So very good question. Actually, this kind of question do comes in the exam, and to avoid confusion, if you've done this one, you will remember that momentum is a vector quantity, and the way we find the change in the momentum, we have to take care of the signs and accordingly proceed like that.